Hey guys, welcome to my channel. So tonight I'm going to do a little demonstration. Quite a few of you have been using ChatGPT, so I used them to do some calculations. And we'll just start off with the motor. This is my Bedini motor I saw on my website. It has 8 neomagnets. Yes, neomagnets, and they're double stacked. And then my coil is 475 turns with my typical Bedini circuit. Actually going to be running on generator mode tonight for this demonstration, and so this is our run battery right here, so 13.24, and then our charge battery right here is 13.28, and so our input black and red, and then I have the scope hooked up to it, so you'll also be able to see that, and our output right here goes through a capacitor, through a diode, through the amp meter, and then to the charge battery. That way it's really clear to see how much power is going through there. And yeah, so let's fire this up. Just going to give it a little spin. I already have it pre-tuned for what we're doing tonight. And yeah, so here's our scope shot here. This is how I like to run it. Get quite a bit more pulses, so we're doing 4 pulses per magnet per rotation, so quite a bit more than just 8 pulses. And let's let this get up to speed a little bit. So I think we're pretty stable now. So let's check the RPM. So we're 259. So 259 RPMs, and then our battery we're running at, this is our N, 0.144 times 13.18 volts. So we're just going to multiply these out. So 0.144 times 13.18 equals 1.89. Okay, and then our output, we need to put the voltmeter onto the capacitor here so we can see the voltages going into the battery. And then here's our amperage. So going out, charging a second battery, our amperage is 0.1025 times 14.03. So we're going to do 0.1025 times 14.03, which equals 1.43. And then to see what our input to output is, I'm going to clear this out. We're going to do 1.43 divided by 1.89, which equals, so we're 75% at the moment, depending on our tuning. And so what I did was I subtracted. So we'll do 1.89 minus 1.43, which gives us 0.46 watts. So 0.46 is basically what we'll be using if we subtract the output from the input. And so yeah, that's our basic number. So what I did with ChatGPT is, from earlier, I gave ChatGPT the specs on the fan, which is this one, and then I had it do a calculation that determined, at the time it was 257, and we're a little bit faster tonight, but I had him do the calculation of watts required to run the fan at 257 RPMs. So it says mechanical need based purely on fan size, shape, and rotational dynamics without assuming motor efficiency. So this is what it calculated here. Estimated torque. And then this was from previous 16-inch plan. And then calculate mechanical power. These are all the equations that it did. Final answer, it says the power required to run the fan at 257 RPM is approximately 0.54 watts to 0.8 watts. So to calculate the efficiency, it did these equations. So minimum output power would be 0.5 watts, maximum output power would be 0.8 to run this fan that I'm using tonight at that specific RPM. So it calculated based on my amperage reading, which is based on this. Efficiency ranges between 134.5% to 200% efficiencies. And this is what it said about it. Since efficiency exceeds 100%, your system likely benefits from momentum conservation, pulse energy input, and possibly magnetic assistance. So pretty interesting. Pretty detailed little thing. So yeah, I just pulled this off the internet and uploaded it to ChatGPT, and it did a basic calculation of it based on diameter and material and everything like that. So it's pretty neat. It was just a simple way to try to see what the efficiencies are, and based on that amperage, it's pretty efficient. So that's what ChatGPT says, 134 to 200% efficient. So by calculating our run battery and our output battery, we could subtract the two to get the actual power use of the motor, and these batteries can be swapped. So yeah, it's kind of neat. So let me know what you guys think. Thanks for watching.